kids. I'm gonna show you how to find the direction of the force. So far you should know this is true. This was from that last video that, hey, you know what? The force depends on this. It also depends on, I should have mentioned this, I didn't, and I should have, sorry. But it also depends on that. That's the equation. Because this angle is the angle between those two, where in the problem that I showed you, we had a horseshoe magnet like this, okay? And I had a wire that was going like this, okay? I had a wire coming this way, which if we were representing that wire, we would have to look at it like this. Hey, that's a dot to show that the current's coming out of the page. But I didn't show you this in the last video, and I apologize, I should have. If I had the current going that way, so like, you know, I move my horseshoe magnet, so it's kind of on top of the wire, I wouldn't get anything because the angle between I and B would be 0. Sine of 0 is 0, so you'd get no force. Like in this setup, if you look, I is pointing this way, positive Z direction, okay? The magnetic field is pointing that way, positive X direction. So look, 90 degrees, there we see it? Okay. So I should have mentioned that in the last video, but I didn't. But, so we're going to talk about how do you find the direction of the force. So that formula was how do you find the magnitude of the force, so the direction. So to find the direction, we are going to use the second right-hand rule. Okay. Now, first of all, you got to go like this. Okay. Now, for you, it's going to be like this, you know, because you're going like this. See how this one makes an L? That's your left hand. You don't want to use your left hand. You want to use your right hand. So the reason it's called the right-hand rule is because you have to use your right hand. So make sure you're using your right hand. Then what we're going to do is, just like the first right-hand rule, your thumb points in the direction of the current, okay? Your fingers were in the first right-hand rule, your fingers were the magnetic field, but they were curled to show the direction of the magnetic field around this wire. Now they're going to be straight because they're going to be the separate magnetic field. So your thumb points in the direction of I. Your fingers are straight, and they point in the direction of the separate magnetic field. Okay, that would be the magnetic field from the in this case the magnet, and then your hand, if you are your palm, points in the direction of the force. So this is easy to remember. Okay, if you're going to push on somebody, you're not going to poke them with your fingers. You're not going to jam them with your thumb. You're going to push on them with your palm. So your thumb points in the direction of the force. So current, separate magnetic field, force. So again, we had a problem like this guy. North, south. Okay, my current's going this way. So if I was doing this, okay, and you're gonna need to do this with me. So, you know, don't just think, oh, I can just watch and understand. No, you're gonna have to actually try it. So, hey, my thumb is pointing this way. So if you were watching on your iPad, your thumb points out of your iPad. You guys understand that? So this way, my fingers are pointing in the direction of the separate magnetic field. So it's going to go north to south. So I'd keep my thumb this way, fingers pointing this way. So hey, look, my palm points towards the top of the, you know, towards the ceiling, or, you know, towards the top of the board here. So the force would go that way, okay? So I'm going to write a couple more examples, and then I want you to practice them. But it is really important that you can do this, and you got to use your right-hand rule. So let's do a couple examples, and then you can practice. So let's say I have a separate magnetic field pointing this way, and I have a current going that way. Okay, I'm gonna write them. You guys should write them too, but see if you can set it up and do it. So let's say I have a horseshoe magnet south-north, and my current is going into the page. So that would be this is my I. Let's say I have a magnetic field, and my current is going that way. Let's say I have my separate magnetic field is like this, and my current is going that way. And then we'll do one more example over here. Let's say I have my magnetic field going this way, and my current is going that way. So I would recommend pause the video, see if you can do it. You use the right-hand rule, and then come back and watch me go through it with you. So pause it. Okay. All right, welcome back. All right, if you're doing this one, thumb, again, you're practicing this. Thumb is pointing the direction of the current. Fingers point in the direction of the magnetic field. So then the force is pointing this way. That would be the positive Z direction. That would be out of the page. That would be a dot. So the force is represented by a dot. Okay? If we were doing this one, current going into the page, my fingers have to point, let me do it this way, here, here. So then my force is going to be that way to the left in the negative X direction. If I was doing this one, current, magnetic field, force is going to be into the page. So that would be an X, the negative Z direction. This one, current, magnetic field is in, boom, boom, force is to the bottom of the page, negative Y direction. And then this one, current, magnetic field. All right, so just, okay, try this at home. Snap off your thumb and then put it on the, well, you know, there's not going to be a force. This is one where the angle between B and I is going to be 180 degrees. Sine of 180 is nothing. So that one would be no force. All right. Bye, kids!